Hello everyone, welcome back to Oceanography. Today we are going to look into the major deposits of the ocean floor that we call as marine deposits. The unconsolidated layer of sediments is commonly termed as ocean deposits. Thus, it is the outcome of deposition of sediments due to the continuous wearing of rocks along with other materials like plants and animals on the floor of the ocean. According to this definition, only the unconsolidated material deposited on the seafloor is considered as ocean deposit. If it is a consolidated one due to one or any other reason, it will not be treated as ocean deposits. There are different varieties of large deposits on the ocean floor, like rocks, pebbles, shale, silt, and organic materials. Ocean deposits are classified on many bases, out of which the origin of deposits and the depth of the ocean are considered to be more important. Depending upon their origin, the ocean deposits are divided into two broad classes, the terrigenous deposits and the pelagic deposits. The word terrigenous has been derived from the Latin word terra and gene, which means land and origin respectively. Hence, the terrigenous deposits are derived from land and are brought to the ocean floor by various agents of gradation like rivers, glaciers, wind, and sea waves. Most of these terrigenous deposits are concentrated on the continental shelf areas. Some of them can be found at greater deposits. These deposits are composed of grains of different sizes and their size decreases with the depth of the ocean. Depending on the size of the grains, the terrigenous deposits are further classified into gravel, sand, and mud. Gravel are generally rough deposits with a large size of grains, where its diameter varies from 2 to 256 millimeters. They do not move far into the sea and are mostly found in coastal areas. They have been given different names according to the size of the grains. Granules are generally considered to be greater diameter of more than 1 millimeter, but it should not exceed 2 millimeter. Pebbles are generally having a size ranging between 4 millimeter to 64 millimeter in diameter, and cobbles are generally larger gravels having a size of more than 64 millimeter in diameter. Sand is slightly lesser than that of the gravel. This is generally deposited by river, wind, and ice waves. The diameter of the sand particles varies from 1 millimeter to 1 by 16 millimeter. Sand is divided into 5 major categories depending upon the size of the diameter of the particles. They are very coarse sand having a diameter of 1 millimeter, coarse sand between 1 to 1 by 2 millimeter in diameter, the medium sand with 1 by 2 to 1 by 4 millimeter diameter, very fine sand with 1 by 4 to 1 by 8 millimeter in diameter, and extremely fine sand having less than 1 by 16 millimeter in diameter. Mud are very fine grained deposits whose diameter varies from 1 by 32 to 1 by 8192 millimeter in diameter. They are found at a very greater depth after the deposits of sand. However, it should be also noted that there is no definite boundary between the sand and mud. Muds are generally having a variety of colors. Murray has identified 3 major types of muds depending upon their color. They are blue mud, red mud, and green mud. Blue muds are formed from those rocks which have larger proportion of iron sulfide and organic matter. It is available in almost all the major oceans. It is generally found near the continental shelf at a distance of 300 to 500 km from the coast. This is the most widespread mud on the ocean floor. It covers almost 104 lakh square kilometers in Arctic Ocean, 78 lakh square kilometers in Pacific Ocean, and 52 lakh square kilometers in Atlantic Ocean. Red mud is red or brown in color due to the prominence of iron oxide. This is found comparatively lesser areas, and hence the red mud is confined to Yellow Sea, Brazilian coast, and some other areas of Atlantic Ocean. The green mud is formed by the silicates of iron and calcareous fossils. It got its color green due to the presence of potassium silicate. It is found in those areas where the coastal area are generally hills and there are no major rivers of discharge. It is mostly found in calm seas. The green mud are generally found all along the Pacific and Atlantic coast of North America, Australia, Japan, South Africa, and South America. Besides these, there are two more varieties of muds, as suggested by Murray. These are the volcanic mud and the coral mud. The volcanic mud comes into being due to the volcanic eruptions. It is generally found in shallow areas near to the volcanic islands. The coral muds are formed by the corals and other volcanic deposits. These are generally found near to the coral islands. The pelagic deposits are those deposits which have been obtained from the seawater and are deposited at the ocean floor. The word pelagic has been derived from the German word pelagos, which means sea, and thus it got the name the deposits that originated from the sea, which termed as pelagic deposits. These deposits are mainly found at a greater depth in the deep sea plain. Some of them are found on the continental shelf and the continental slope areas. The pelagic deposits are further categorized into two, the organic deposits and the inorganic deposits. The organic deposits generally contain the fossils of fauna and flora. On many parts of the continental shelf, both animal and plants live and give in multiples, and their shells and skeletons may form the greater part of the deposits. These type of deposits are not found at a greater depth due to the shortage of food and light. Most of the organic deposits are generally of fine particles, which we term them as ooze. These organic deposits are further classified into two categories, the calcareous organic deposits and the siliceous organic deposits. The calcareous organic deposits are further classified into TERRIGENOUS and GLOBIGERINA ooze. The theropod ooze are generally the shells of certain class of floating molluscs, which are known as theropods. These shells are always thin and often more or less conical in shape. The theropod ooze occurs chiefly in the ridges and plateaus which rise from the deep sea plain where the water is comparatively shallow. They are generally found at a depth about 800 to 1000 fathoms, but sometimes you can find it extended downwards up to 1800 fathoms. The theropod ooze flourish most abundantly where the surface water is warm and the annual range of temperature is small, and the deposits is therefore found mostly within or near the tropical areas. The Globigerina ooze is generally made up of calcareous shells of Foraminifera. The Globigerina being the most abundant and widely distributed genus, the shells are always small and commonly about the size of an ordinary pin. And this is most widespread type of ooze in the Atlantic and Indian Ocean. It is always deposited either in the warm or the temperate seas. Generally, you can find the Globigerina ooze at a depth ranging from 1,500 to 2,000 fathoms. As the depth increases, these will gradually disappear, giving place to red clay. The siliceous organic deposits are generally formed from those organisms which are dominated by silica. They are further categorized into two, the radiolarian and the diatom ooze. The radiolarian are minute organisms belonging to the same great division of Foraminifera. Their shells or skeletons are made up of silica instead of carbonate of lime. Radiolarian ooze occurs only in deep waters and is seldom found at depth less than 2,000 fathoms. It is confined to tropical areas and occurs chiefly in Pacific Ocean and to a smaller extent in the Indian Ocean. However, it is not known in Atlantic Ocean. The diatom ooze belongs to the vegetable kingdom and are in the generally of microscopic in size. Their skeletons made up of silica and flourish principally in colder areas. This type of ooze is chiefly found at a depth varying from 600 to 2,000 fathoms, but even it can be found extended up to 4,000 fathoms. Generally, it is found in southern oceans. The inorganic deposits are generally dominated by iron, manganese, silicate, dolomite, pyrite, feldspar, and they lack organic matter. They are further classified into red clay and meteoric dust. Red clay is the most widespread of all the pelagic deposits. In composition, it is a true clay consisting mainly of hydrated silicate of aluminium, which is colored by the oxides of iron. It is not found above 2,000 fathoms. It covers more areas than any other type of deposits. It almost found half of the Pacific Ocean and also larger areas of Indian and Atlantic Ocean. The red clay is apparently formed by the decomposition of volcanic material which is carried out in the sea. The meteoric dust are heavenly bodies which are attracted by the earth due to the gravitational force, and hence most of these meteors, when they get burnt as a result of the gravitational and atmospheric friction, the ashes produced by the burning of these meteors is deposited on the ocean floor and forms as ocean deposits. However, the process of these deposits are very low. Friends, I hope you have enjoyed today's session. For any doubts or clarifications, please post in the comment box or in the Edmodo. I wish all of you a great day. Thank you all.